This is Software Engineering Radio, the podcast for professional developers, on the web at se-radio.net. SE Radio brings you relevant and detailed discussions of software engineering topics at least once a month. SE Radio is brought to you by IEEE Software Magazine, online at computer.org/software.
Welcome to a new show on Software Engineering Radio. Our topic today are massively open online courses. My guest is Doug Schmidt, and I'm the host, Michael. Doug Schmidt is professor of computer science at Vanderbilt University and is going to teach his first massively open online course in spring next year. Welcome, Doug.
Good afternoon, Michael. It's great to talk to you again.
Doug, please give us an overview on your involvement in massively open online courses and how come you're doing your first course in spring next year.
So I've been teaching courses related to software, especially software for distributed systems and embedded systems and real-time systems for close to 20 years now. And during that time, I've probably taught roughly 50 students a year in a traditional face-to-face immersive classroom environment. So over 20 years, that's about 1,000 students or so. For a long time, I've been really fascinated with how we can improve the way that we teach courses to the students we meet in a face-to-face environment. But up to this point, it's really been about me devoting extra time after class, me devoting time individually to work with them one-on-one, which just doesn't scale up very well, even though we're fortunate to have a small number of students. So one of the reasons why I'm teaching this course is to get a chance to start to learn and experiment and prototype different techniques for teaching my courses more effectively by using digital learning technologies. And as it turns out, there's been a lot of really exciting developments technologically in the space of massively open online courses, or MOOCs, over the past year or so, as people have started to use these as a way to get a much broader dissemination of knowledge to the broader community. And so what I'm planning to do here is I'm going to be teaching my first MOOC in early February for 6 to 8 weeks or so. And as I do that, as I develop the course material, as I develop the various assessment tools, the online quizzes, the online programming assignments, the online grading, and so on, I'm not only going to get experience teaching people in a massively open model, but I'm going to take the material I develop and then feed it back into my immersive face-to-face courses that I do here at Vanderbilt for the students I work with. And I think the exciting thing about that is it'll give me a chance to do a more effective job of teaching face-to-face by taking the technologies and approaches that we use for the massive market and then finding a way to make them work in a more personalized way for the individual students.
Okay, so let us get back to disseminate the term MOOC. So how it stands for massively open online course. I mean, course is clear, but what is so massive about it?
Well, so I gave you the example before of teaching about 50 students a year for 20 years, giving me about 1,000 students during my career thus far. In the first week of the announcement of my MOOC course, which will be on patterns and frameworks for concurrent and network software, I had 2,000 students in the first week. And a couple weeks into this, we're now about a month and a half or so after the announcement, I now have around 10,000 students enrolled in my course. It would take me about 1,000 years to teach 10,000 students in my traditional face-to-face way of doing things. And I have a feeling by the time the course goes live in the February timeframe, I'll probably have something more like 30 to 50,000 students. So that becomes pretty massive by almost any definition of massive. And part of the goal, part of the challenge technologically here is to leverage digital learning methods and tools so that the students who take the course, the 50,000 students or 30,000 students who take the course through distance learning, get almost the same quality and sense of intimacy that they would get if they were to be in my face-to-face class. So that's part of the massive nature of it. Obviously, when I teach my courses for the students here at Vanderbilt, I look at every one of their programming assignments by hand, and I provide them with extensive comments, and then they give me back their improved version, and we use that as the grading, as the final grade for the project. When you're teaching 30 to 50,000 students, there's absolutely no way one human being, even with an army of TAs, teaching assistants, would be able to keep up with that kind of volume. So we're going to have to come up with new approaches to automating the assessment, automating the grading, automating the quizzes, automating the programming assignments, and so on, so that people can get good feedback, but we can do it in a scalable way. So that's a lot of where the massive comes from, just the sheer number of people involved.
And then the next term, it's open. Is it open as in open source, meaning free?
Yes, this is actually in the use of open in the sense of open or free being free beer as opposed to free speech. So the courses that we're doing, which is through the Coursera organization, which is a consortia of about 33 top universities in the U.S. and around the world, all the material that they're doing in Coursera is available for free online. And we're very fortunate that Vanderbilt University has chosen to make the investment in both time and resources, my time and the resources of people who will help produce the course from a video production and editing point of view. We're very fortunate they have agreed to do this, and then we'll make that content available literally to anybody anywhere in the world who has access to a computer network and a browser, effectively. So that's what makes it open. And right now, you're not going to be getting a course credit from Vanderbilt from taking this course. But I suspect over time, as these things mature and evolve, and we address issues of how do you make sure that people aren't cheating, and you make sure that people who are taking the course are doing their own work and so on, I suspect you're going to start seeing some type of certificate program or grading or credit being provided using this material that we're producing as part of this exercise.
And the next term would be online. I mean, that is clear. It's an online course. So we clarified that. You mentioned Coursera. So is it the only provider of such MOOCs?
There's a number of MOOC providers at this point. Some of the early work was done by the folks at Stanford University, Andrew Ng and Daphne Kohler, who are the co-founders of Coursera. They came from Stanford. They were professors there, and they became the co-founders of Coursera. And they're one of the leading organizations doing this with, again, roughly 33 or so universities from around the country, the U.S. and around the world. There are also a couple of other groups. There's a group called edX, which is Harvard University, MIT, University of Berkeley, and I believe University of Texas at Austin just joined edX as well. Don't quote me on that, but I think they have 4 organizations now, and they're offering courses. There's also some other ones that are a little bit less formal. There's the Khan Academy, which is mostly through sort of YouTube-like videos showing very specific kinds of techniques and approaches to learning. And then there's also another group called Udacity, which, as I understand, is a for-profit organization. But I suspect we're going to see a lot more different business models, a lot more different approaches in this space over the next year or two, because it's a rapidly growing ecosystem. And a lot of this is driven by the fact that, as Thomas Friedman once said about this particular topic, great breakthroughs often occur when what is suddenly possible meets what is desperately necessary. And trying to get a handle on the cost of higher education on one hand, and then being able to provide good quality education to many people, all people around the world, those are two interesting forces that have been working for quite a long time. And because of the advances in digital technology over the last decade and the advances in broadband network access, we're finally at a point where many people, in fact almost everybody in the world, will have a chance to avail themselves of a body of knowledge that heretofore has only been available to people in the upper ends of the economic strata, people who are able to go to the top universities in certain countries at certain times.
I mean, as you mentioned bandwidth, what kind of prerequisite would be needed for such a course?
I think you typically need basically broadband access. If you've got enough to be able to, at the very least, listen to audio versions of the material, maybe watching slides and listening to the audio, that's probably the bare essential. Most of the material that's produced for Coursera and some of the other ones would also require some video display as well, but that's probably not quite as important as the ability to see the slides and listen to the audio track. For the most part, the video production is mostly just to give you a little bit more of a feeling of talking or listening to a real human being as opposed to just listening to books on tape kind of a kind of a session.
Is it true that it started off from the computer science community, computer science professors? If I'm not mistaken, the founders of Coursera are both professors of computer science, respectively machine learning.
Yes, that's right. They had particular specialties that have become extremely appealing today. They did a lot of work on things like machine learning and data mining, which, of course, as you can imagine, in this day and age of search engines and search optimization and unstructured data analysis, data analytics, and so on for many, many different purposes, for advertising, for homeland security, for other kinds of purposes, knowledge learning, and so on. People really had an interest in knowing how to apply various artificial intelligence techniques and machine learning algorithms in order to be able to be effective at this brave new world of big data analytics. And so they discovered a couple of years ago, probably 2009, 2010, that there was a demand for the kind of courses that they were teaching at Stanford. And they had pretty much maxed out the number of students that could physically sit in a lecture hall at Stanford University and get anything useful out of the course. I think they had roughly 400 students in the class. I think the first time they taught the course, this was probably Andrew Ng, he had something upwards of 100,000 students the first time he taught the course online. So at that point, they began to realize that there was an amazing ability of being able to transform the educational experience to give a lot more people access to their knowledge, to their material, to their expertise than they ever could possibly afford to do in the traditional face-to-face type of model. So that's kind of where things started. They weren't the only ones who were doing this, though. There were other people. I believe it was the Khan Academy. The guy discovered that he wanted to be able to teach some of his family members various types of mathematics, and he was able to use YouTube videos to instruct them from a distance. And he discovered this was a real popular way to teach a lot of different topics. And so the work that Khan Academy has done has really sprung from trying to help educate a local community, and that, of course, has turned out to be a very valuable technique to educate a broader community as well.
You mentioned briefly the predecessors. So what were the properties or the disadvantages of the previous models that resulted at the end in the MOOC evolution and the MOOC success today, which we didn't see with the previous methods, approaches so far?
Sure. So there's a couple of different answers to that. I think one of the things that we've seen is that simply doing the intuitive and somewhat naive approach of taping someone giving a talk, which is the way that most people have historically done lectures, just a person standing in front of a group of people giving a lecture. That approach, while it works reasonably well in a small group environment face-to-face, doesn't really scale up to the capabilities of a massively open online course environment. So people have had to rethink the way in which they produce the material. And we're benefited here, of course, by the fact that there's now a lot more expertise in the form of being able to capture voice and video through things like Skype or things like various editing tools you can have on your PC or your tablet, and the ability to manipulate those things to create fairly sophisticated, intuitive, nice, fun, informative video production capabilities on a budget. You don't need to have a tremendous amount of investment to do this. So part of it's been the advance in computer editing and computer manipulation of voice and video. So that's part of it. The other thing, though, I think that's even more important is access to the expertise base, the body of knowledge that's so crucial to making this work. If one or two people try to come up with a set of courses, they're very quickly going to be limited by the scope of their expertise. And while there certainly are many, many talented people at universities who are capable of being able to teach on interesting subjects, the problem is that they are usually experts at a handful of topics. But what you really need to build a curriculum is a wide variety of topics, say the topics you would expect to find at a top university almost anywhere in the world, where you've got many experts. So one of the things that I think the folks that the Coursera have done a really good job of is putting together a team of the top professors at the top universities around the world, because that gives them access to expertise. That gets them access to some of the most informed and dynamic and charismatic professors who can talk about subjects that they know and love and have a great degree of experience and knowledge in, and then they can individually record stuff that is relevant for what they do, but then collectively Coursera can package together all that material to give pretty much, maybe with a few gaps, pretty much give a comprehensive undergraduate education in certain areas. Just as one example, I think at this point the Coursera offerings for computer science are almost sufficient that you could teach pretty much an undergrad curriculum in computer science that would be probably superior to almost everything you could imagine at most of the universities in the world today, because they're able to tap into experts from all the top places.
Wow. So is it especially suited for computer science topics, or is it also applicable to the whole broad set of topics taught at universities?
Well, interestingly enough, again, speaking for Coursera, I'm sure the other groups have similar experiences. The most popular course that they have right now is Introduction to Finance and Accounting. For whatever reason, that course is just off the charts in terms of interest. Another course that's very popular is a course that's the history of the 20th century, which isn't anything at all like a typical computer science course. I think realistically speaking, at this point, given the technology we have at our disposal, the kinds of courses that work best on Coursera fit into two categories. One, there's a way of being able to do some kind of online interactive assessment, which works pretty well if you have multiple choice questions, short answer questions, true-false questions, maybe some programming assignments and so on. But of course, doesn't really work well if you're trying to do laboratory experiments involving chemicals or lab animals. You're not going to be able to hook those things up to your computer and do anything sensible. So some of the arts and sciences courses that involve a studio model or experiments that are not easily turned into cyber interactions them are more difficult today to do. But the technology is rapidly evolving. So one of the things that Coursera folks are able to do at this point is they're actually able to do peer grading for things like short answer questions or essays that you would expect to find in various humanities disciplines such as English or literature. And that was up to this point sort of out of reach of earlier people who tried to do these kinds of online assessments, because they had to have humans in the loop in almost every place, and without the massive body of students who are willing to spend time doing assessments of each other's work, it's very difficult to scale up the assessment and evaluation part. So I think to answer your question in a nutshell, the computer technology has gotten much better to be able to produce these courses online in a cost-effective way to give the right quality with the right dynamics that are effective for computerized learning. And we now have a way of being able to leverage the huge body of expertise of people who are able to teach courses that work well in a digital environment. I should also point out one more thing that's relevant in this space. When people are first confronted with the concept of digital learning, there's a tendency to think, gosh, I remember back to my days as an undergrad, sitting in a small seminar course, being able to involve in a deep discussion and debate with my professor face to face, and how enriching and how stimulating that was. And I can't possibly see how watching videos on a computer could anywhere near rival that degree of interactive learning. And I think when we think like that, we tend to perhaps romanticize what many people's education experience is these days. An awful lot of people, when they go to college, aren't sitting in courses with a professor and 10 other students. They're sitting in a large lecture hall with 200 to 300 other students, and somebody, a little blip down on the stage, is giving a talk, and the students are half listening, they're surfing the web, they're tweeting their various things and text messaging each other, and the lecture environment really isn't as much about interactive teaching and learning as it is about one-way flow of information. So the first thing to remember is that that's what many people experience these days in education. The second thing that's worth noting is that in those kinds of environments, and quite frankly, even in traditional smaller classroom environments, only a handful of people at any given point in time, only a handful of students, are actually engaged in two-way interaction with the professor. I know that when I'm teaching material on software patterns or software frameworks or distributed systems or concurrent network programming. I'll be lecturing and asking questions and seeing if the students have their thoughts to share. And at any given point in time, in a class of 15 to 20 people, only a handful of people will raise their hand, and maybe only one or two people will get the question answered correctly. So what's happening there is most people are listening, hopefully they're following along, but they're not really participating in any deep way. In contrast, in a well-produced digital learning course, every 3 to 5 minutes, we can pop up a question to ask students to make sure that they've understood what was just covered on the previous slides. And we can make sure that every single student, all 50,000 of them taking that course, has all got a chance to answer that question and answer the question correctly before they're able to go on and hear the next part of the lecture. So that's a technique in the pedagogy literature called mastery learning. And it turns out when you start to do mastery learning, the students tend to follow along more closely. They can't make progress until they've mastered some set of material. And as a result, there actually potentially can be more interaction for more students than you would typically find in your normal face-to-face classroom, where only the people who are extroverts and highly motivated to answer questions tend to be the ones interacting with the professor. So I think it's important that we remember, that not everything is a seminar, and even in seminars, not everybody's participating all the time. So there's a real opportunity here through digital learning to improve the degree of participation of all the students, not just the ones who are most comfortable raising their hand.
Your topic will be on patterns and frameworks. You're teaching the class you're teaching in spring next year. What are your personal experiences now preparing for this class? Do you have to restructure and reorder all your material? Will you have to change all your programming exercises? I guess for the programming exercises, yes, but for the other topics, please share some of your insights.
You bet, absolutely. I've been teaching courses on patterns and frameworks for network and concurrent systems for decades now, and I've got quite a large volume of course material on this topic, slides and assignments and quizzes and so on. And I've had to rethink things quite a bit for this class. Just to give you a couple examples, normally if I would teach this class, I would probably only focus it on a particular programming language. So for example, if I've taught the class in a distributed real-time embedded systems context, I would probably focus on patterns and frameworks in C++, because that's very common in that space. Conversely, if I was teaching a course maybe for smartphone developers, I would probably maybe teach it in Java. The point is that when I teach a course in a face-to-face environment, I pick a language, typically pick a handful of systems to use, and that's what we do because it gets too complicated to try to teach multiple languages, multiple systems all at the same time. When I'm doing the course for the online version, in contrast, what I'm going to be doing is I'm going to be talking about a topic, and I'll be presenting a pattern-oriented solution to the topic first without necessarily having to dedicate or hard code the discussion to a particular language, to a particular system. So we can talk about the patterns for developing user interfaces, or we can talk about the patterns for developing a high-performance web server, etc. And we can talk about those patterns in the classic pattern language way. We can talk about the patterns, their roles and responsibilities, the dependencies they have on each other, the way in which a sequence of patterns can be used to resolve certain forces in the design space, and so on. And then what I can do when I've done recording that module, and each module is roughly 15 to 20 minutes long on a particular topic, then I'm going to go back and I'm going to record different versions of those patterns demonstrated with a particular language, with a particular technology. So we might talk about a web system or a web server, and then I would show how you could implement that pattern language for that particular application using, say, C++ with ACE. And I can record that, and I can show how those patterns are instantiated into something concrete. So people who are following along, who want to see more than just the design aspects, can actually dive down and look at the solutions in code and in detailed design. And if you're a C++ developer, that's probably the path for you. Conversely, if you're a Java developer, I'll have a different track where we can do the same thing. We can show the pattern language as it's implemented in Java. And maybe we'll show one where we might implement it in Java using, say, Android. So people who have a different set of interests can follow a different path through the material. They'll all get a chance to understand the patterns in their more platform and language independent way, but then through the magic of digital technology, different people can take different paths through the course that most match their particular needs. And that is absolutely something I've never been able to do when I've been teaching my courses heretofore, because we just didn't have the resources and the time to do that. So this will be a very interesting approach. Of course, this makes it a little bit more complicated because we have to record multiple versions of the patterns, but I think the end result is going to be worthwhile. Now, just to bring this back to what we had talked about before, this is also exciting because once I create this material, what I can do when I teach my face-to-face class next fall is I can take the video content I've created for the online version and I can put it into something known as a flipped classroom model. And so what I can do is I can ask my students in my face-to-face class, of which they'll probably be more like 30 to 40 as opposed to 50,000, I can ask them to watch small 15, 20-minute video modules on the material before they show up to class. And I can make sure, through the magic of the online grading and online assessments, whether those students actually understood what they just watched. So they'll have to fill out the questions, they'll have to do the quizzes and so on. So by the time people show up to my actual face-to-face class, I'll have a very good idea of what they understand, what they don't understand, and how I can cover the material face-to-face in a way that will deepen the understanding that they got by watching the video. So that's called flipping the classroom, and it allows you to spend more time in the class in a design studio-like approach, giving people much more tailored help, much more tailored responses, much more tailored input for weaknesses you've identified because of the fact that we've leveraged the digital learning material ahead of time.
This sounds really cool. So I wish I would be back in student days. Great.
Well, the great thing, of course, Michael, is you don't have to be an undergrad or a grad student anymore to leverage this. In fact, the Coursera people have found that the bulk of the demographics that they have identified as people taking the courses these days are between 30 to 50 years old. And so what they're finding is many of the students who are actually attending the courses are working adults who are coming back to get that specialized education that they might not have been exposed to when they were undergrads, because technology has moved so fast in the meantime that the material they learned is perhaps no longer what's being useful for the jobs that they're being asked to do at work.
Cool. So, what kind of exercises are you selecting, and what kind of grading system did you come up with for your course?
So there are basically two different types of evaluation mechanisms we'll be using. One type is going to be the pop-up quiz, probably multiple choice, maybe short answer, where we just kind of make sure the students have been following along for the last 5 minutes or so of the lecture material. Every 3 or 4 slides, you pop up a little quiz and say, what was the intent of the pattern we just covered? Or which of the following are the forces that are resolved by this particular pattern? Those kinds of questions. Or what is the definition of a framework? So you can basically make sure the students are paying attention and not just snoozing and just basically not really getting out of the material what you'd hope they'd get. So that's one approach, and those can come up very frequently. At the end of every module, we'll also have some programming assignments. And again, this is still kind of a work in progress, but what I hope to be able to do is allow people to be able to write the programming assignments in either C++ or Java, and then they'll be able to submit them, and depending on how clever we can get in terms of our ability to parse the submissions and grade them and review them, at the very least we can review them to see if they work or not, i.e. they produce the right result. So that's kind of the easiest thing to do. And then perhaps for some of the assignments that are in a language like Java that's got some reflective capabilities, we can actually develop auto-grading tools that will go in and look for certain style or structure mechanisms in the code as well. That's a little bit more of an ambitious thing because that's really getting into more of the subjective qualities and qualitative aspects of assessment. So I'm not sure if the technology is quite ready for that, but I think looking ahead, where I see the field going over the next few years is people using platforms like Coursera to develop much more sophisticated automated grading techniques. which of course will work well for these large MOOC classes, as well as maybe work for the face-to-face ones as well. Right now, I do that kind of work myself when I do the pre-screening of my students' assignment submissions. I go through and I basically play compiler. I play syntax and semantic style editor and so on. But that takes a lot of time, and it would be nice if we could automate that so I could really zoom in on the things that were the really important stuff, which was understanding design, understanding optimization techniques, understanding the implementation approaches that are not easily learned just by reading a book.
I have to tell one anecdote. When I was in your research group and I would have coded something, I would have to first show it to you, of course, in the first submissions. Only later it got more relaxed. But on the first submissions, I saw that online parser and online editing, and it was just amazing how the lines just moved back and forth, and was a great learning exercise. So I wouldn't have wanted to miss that in the past. So thanks again for that. So I know how you work as a parser.
Yeah, and it's great. It's great to be able to do that for a dozen students. It's going to be a lot harder, obviously, to do that manually for thousands of them.
So for the programming assignments, it will be difficult, and we will have to advance technology and our experiences to do that right. So it seems like we are more at the beginning to grade programming assignments.
That's right. And I think another thing that's worth mentioning here is obviously the whole issue of people doing their own work. One of the impediments at the moment to a broader adoption of online courses in mainstream education is the concern that the people who are submitting the work aren't the people who are actually taking the class. You can imagine a world where you could outsource, you could have low-cost places in the world that would do your homework for you, and then they would give you the solution, you could submit it. And so obviously there's a lot of capabilities, there's lots of demand for people doing various kinds of plagiarism detection tools to detect this kind of thing. And there's been a lot of good work that's been done for many years at various universities around the world to do that. But now we have a context in which we can apply it. We can get tons of data. We can continue to improve the static and dynamic analysis techniques to detect that kind of plagiarism. And I think that this is something where technology will play a large role in being able to solve the issue of ensuring that the students do their own work and they get credit for the work that is their work as opposed to somebody else's work.
We talked already a bit about the application of the learnings from the online course to an immersive learning class. Is there any more about it, how the learnings and findings, experience, and the online courses would benefit the classroom students?
Absolutely. And I think a lot of this has to do with sample size. If you teach a class with 15 people in it, many of the courses at Vanderbilt are relatively small. We have 15, 25 students or so. You have a relatively small sample, and that sample, of course, tends to be students that are generally pretty well educated and reasonably well motivated, et cetera. So it's not always clear, how they are learning, what are some stumbling blocks that are vexing them all, and especially if you don't have the kind of course, the design studio-like course I typically teach where I look at all the programs. You can imagine if it was a more traditional course where people were graded by teaching assistants only and so on, it might not be easy for a professor to know what was confusing the students. What common approaches that he or she was presenting in the lecture were effective, which approaches were not effective, where were people getting confused, and so on. Because you have no easy mechanism other than a quiz and a programming assignment on a periodic basis to assess whether people are learning. Conversely, if you have 100,000 students taking your course and every 5 minutes they have to do a quiz, you find out pretty quickly what they are understanding and what they're not understanding. So if you give them a question and 30,000 students out of your 50,000 students get it wrong, why is that? Do they not know what they're doing? Did you do a poor job of explaining it? And maybe we could come up with techniques that would, A, help us to do a better job proactively of designing our lecture material to address these common problems ahead of time so they wouldn't be confusions by the time they were tested on it. Or B, if people miss things in a common way, it becomes possible through data analytics and machine learning and analysis to identify common patterns of misconception, which can then be addressed through various hints or other kinds of feedback we give the students when they don't get the problems right. So you can certainly imagine in an online course where you're trying to do mathematical analysis or proofs or something, if somebody submitted a proof or they submitted a solution that had mistakes in it, probably wouldn't be that hard for the computer to figure out why they were being confused, especially if thousands of them were being confused, and then be able to give them a hint, say, you're not quite doing the derivative correctly, or here's a different way to think about integration under the curve. And so a computer is very patient. A computer can take forever to help people master their confusion. A TA, a professor, there's only a certain number of hours in the day, there's only a certain amount of time in office hours, you can only spend so much time on one person. So I think what we're going to see here is the ability to really tailor the educational experience for the individual students in ways that you just can't afford to do with the traditional immersive environment without using these kinds of computer-based tools.
Cool. One question, and I wanted to ask that question in the beginning already. I mean, what makes an university, what makes an expert like you put time into a class and offer it for free?
Well, I think my main interest in all of this is to help improve the face-to-face courses I'm teaching for the students that are enrolled at Vanderbilt. And the fact that we can at the same time help out hundreds of thousands of students around the world is just icing on the cake. But I really see there are three ways that it pays off to my existing employer, Vanderbilt University, to give me the opportunity to do this. First of all, it's going to help the current students that we have at Vanderbilt because we'll be able to start applying these digital learning techniques in a flipped classroom environment as early as this spring or certainly by next fall. And so they will begin to benefit from all the stuff that we're talking about. Second way it helps is it allows the people who are alumni from Vanderbilt, people who were students here, a year or two ago, or 5 years, or 10 years, or 20 years, who are still interested in being connected to the Vanderbilt community. They can go back now and they can watch lectures by their favorite professors or by people who are experts in the field talking about things that may be even more relevant to what they're doing in their jobs than they may have realized when they were here, number one. And number two, the material will have been updated and topics we're going to cover this fall won't have been what we covered 5-10 years ago. When I first came to Vanderbilt about 10 years ago, I didn't know anything about Java concurrent network programming in Android because I didn't know any Java and Android didn't exist. So of course I didn't teach that kind of material for a decade. Now it does exist. Now I've learned it. Now I can convey that. So my students of the past can come back and take a refresher from a professor that they may have enjoyed earlier, me, talking about some new stuff. And then I think the third benefit that it does for my university is it helps allow people all around the world understand the kinds of material that we cover and the quality we provide and the depth of education experience that can be encountered by coming to Vanderbilt. And by doing that, it helps us to attract the best and brightest students from around the country and around the world to want to come here as undergrads or as graduates. So I think there's a lot of ways in which this digital learning methodology helps us to do a much better job in our existing immersive environment. So I don't see it as just giving away stuff for free. I see it as an investment in the future of learning technology in immersion ecosystems, such as a place like Vanderbilt University.
Can I ask you whether you yourself have already taken a MOOC?
I have watched a number of them online in preparation for my course because I wanted to understand the different models people were using to present the material, all the way from just recording themselves giving a lecture with a handheld camera to something more sophisticated and more multimedia enriched. I've also done a couple of recordings for other activities using MOOC-like techniques. So I've got some experience developing these things, the techniques that I find personally work for me, how I like to present the material. And one of the things I'm finding more and more in the work I do is the ability to give webinars or podcasts like this digitally so that we can archive them, so I can expand and reach people in far corners of the country and far corners of the world that I would otherwise have a hard time getting to meet face to face. So I think of this all as a natural extension of things that I've been doing for quite a long time as an educator and as a researcher. But at long last, we have a platform for packaging and delivering this material to everybody around the world, whereas before it was done in sort of a hit or miss like manner for a particular organization, a particular sponsor, a particular group. Now we can do it for everybody.
Where do you see this approach lead into in 5 or 10 years? Any vision about it?
Yeah, absolutely. I think it's going to be a bifurcated model. I think there are going to be some universities who are going to be heavily reliant on the content for MOOCs to either augment some gaps in their existing curriculum or to be able to allow them to reach the number of students they're going to need at a cost that is reasonable and affordable. So, some universities these days are very strapped for funds. A lot of state universities have been getting cutbacks from their state legislatures because of the budget crisis and the economic downturn. A lot of these places have quite a number of students that they have to educate. They don't have the money to hire faculty to teach them all in a face-to-face manner. I think you're going to see a lot of the use of MOOC-like content coupled with face-to-face lectures or sort of recitation sessions or teaching assistants or whatnot being used to augment and expand those kinds of universities so that they can reach the communities they are obligated to serve by the virtue of the fact that they're a state university. So that's sort of one model. The other model, which is kind of more of the Vanderbilt University type of model, the more kind of top-tier immersive education environments, the Stanfords, Harvards, MITs, and Vanderbilts and so on, I see them using this material in a slightly different way. I think they're going to use it to enrich the immersion experience that they already have by the techniques we just talked about, by being able to get access to the best people to augment the quality of their already great faculty. Let's face it, everybody's an expert. Everybody at a top university is an expert in something, but pretty much nobody's an expert in everything. So I would love to be able to, for example, if some of the other great people in the world, like Doug Lee, who's an expert on concurrent programming in Java, or Frank Bushman, or Kevlin Henney, or Michael Kircher, or so on, people who are great at their topics, were to talk about their expertise and record it, I would love to be able to use that material in my classes. And so it'll help make me a more effective professor because I don't have to be an expert in everything. I don't have to try to pretend like I'm an expert in everything. I can leverage the expertise of those people who've packaged their knowledge in a readily digestible form. In many ways, these types of universities are going to be using MOOCs as essentially a multimedia textbook. So students will be able to learn about some topic not only by browsing the web and looking at online documentation or reading a textbook, they'll be able to go and watch a video by the inventor of Java or the inventor of C++ or an expert in machine learning or an expert in real-time scheduling in order to augment and deepen the knowledge that they have on a subject. So my vision of the future is that we'll have universities that are kind of divided into these two camps. One group uses MOOCs as a way to deepen the immersion experience. The other group is using it as a way to be able to serve their population in an affordable way. And of course, there'll be many things in between. Those are just sort of two of the extreme perspectives on how I think this is going to unfold.
I think we covered the topic really well, especially with those last words. Any final words you want to share with our listeners?
Well, I guess the main thing I'd like to encourage people to do is to start sampling the material that's available now, the ever-growing corpus of videos and multimedia presentations available in the MOOC context, and certainly be great to see you in my course that's coming up here in the beginning of February on patterns and frameworks for concurrent network software. And I look forward to getting feedback and other insights from people who've gone through the process and have their insights to share back with those of us who are trying to produce the content most effectively.
Okay. Thanks, Doug, for sharing your experiences with us.
Thank you, Michael. Always a pleasure. Talk to you soon.
Thanks. Bye-bye.
Bye.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more information about the podcast, including other episodes, visit our website at se-radio.net. To support us, you can advertise SE Radio by clicking the Dig, Reddit, Delicious, or /dot buttons on the site, or by talking about us on Facebook, Twitter, or your own blog. If you have feedback specific to an episode, please use the commenting feature on the site so that other listeners can respond to your comments as well. This and all other episodes of SE Radio is licensed under the Creative Commons 2.5 license. Please see the website for details. Thanks again for your support.